And I'm ready. Yes, you said 11, 3.
Yeah.
Okay, 11, 3.
So page 748.
Yes, 748.
Number 23.
23. So let's see what we are asked to do. Find the equation of the hyperbola whose graph is shown. I know a hyperbola of this type is y squared over a squared minus x squared over b squared equals 1. The one on the x-axis, it will be x squared over a squared minus y squared over b squared. But since it's vertical, I have y squared over a squared minus x squared over b squared equals 1. Okay. I see that the parabola crosses, in other words, a is 2. Would you agree? Or a squared is 4. Would you agree with that? So this piece is 4. And I'm given the point 3 comma negative 5. So what I know so far is that the hyperbola looks like this for now. And I am given one more piece of information. What does this say to me or to us? What does this point say? The hyperbola goes to that point. It's like this is a point on a function, or the point of on a graph of a function, or a point on a when x is, y is, that's it. That's what it means. Like any point on a curve or function, correct? We all agree? Yes? So this point says when x is 3, y is negative 5. All I have to do is plug it in and get b, and it's done. Because you have x and y, you're just going to plug them in and you get the only variable that is missing. Is that okay?
Yeah. Can we run through that real fast just to see?
Yeah, y squared is 25, x squared is 9.
Okay. And where's b come from?
You don't have it. That's why you're given this information to find it.
Right.
You have 3 variables, but you are given 2 of them. So you can determine the third one. Let's determine the third one. 1 minute. Let's determine the third one. How much is it? How much is b or b squared? I don't really care for b. I care for b squared. We don't have difficulties with this, do we? Right? It's a rational equation, correct? So how much is b squared? Do we have an answer? Any answer? We do? We don't? So are we having difficulty with this equation?
Just to find the.
How come? 25 over 4 minus 1 equals 9 over b squared. I can add here, it's 21 over 4, 9 over b squared, and I cross multiply. I don't think, I disagree with this. Unacceptable. Agreed? Is that a yes? Is that a no? We agree? We disagree? Okay, so we are on strike then. We'll not ask any questions today then. I know it's not a trivial equation, but we discussed this 100 years ago in August. Right? We isolate the variable, we take that fraction to the other side, and we cross multiply. So 21 b squared equals 36, so b squared equals 36 over 21. And I just put it in here, and done. So y squared over 4 minus 21, because it's in the denominator, so I flip it. 21x squared over 36 equals 1. Is that okay?
Yeah, I think I was confused because
Maybe they wrote it as 36 over 21 in the denominator, which is fine too. But we normally don't like to write fractions over fractions. We simplify. But even 36 over 21 is good.
Yeah, it says y squared over 16 minus x squared over 16.
Equals 1
Yeah,
in 23.
correct.
Let's see what my book says. That's 23 in 11.3. That's interesting.
That's why I was
23. Yeah, let's take a look. 23. And that's 11.3. 11.4, 11.5, 11.3, and that's 23. Y squared over 16 minus x squared over 16 equals 1. Let's take a look again. So 3 comma negative 5. 3 comma negative 5. So a squared is 4.
no, a squared is 2.
No, it's 4 squared.
Yeah.
I didn't square it. Thank you. Thank you. A is 4, not a squared. I agree. So 25 minus 16 is 9 over 16. Yes, b squared is 16. I wrote it as 4, a equals 4, but when I plug it in, I have to write 16. Not 4. Sorry about that. My fault. I identified a, but when we plug it in, I have to have a squared, and I didn't square it. Sorry about that. So indeed, when you cross multiply, indeed you get b squared equals 16. Good point. Thank you. Anything else? Anything else? Other questions? Anything else? Yes, Chris?
Number 7,
Yes, number 7.
the 11.3.
Same one?
11.3.
Okay. Let's look at the same section. 11.3, problem 7. Let's take a look.
Match.
Okay, 11.3, problem 7. Yes. So we want 16y squared minus x squared equals 144. Obviously, I have to do what first? Excellent. So I have 16y squared over 144 minus x squared over 144 equals 1. Since the negative sign is in front of x squared, is this hyperbola on the x-axis or on the y-axis? On the y-axis, very good. So we know for sure that it can be only 2 or 4, correct? Okay. So now I will simplify. So when I simplify by 16, what do I get? 144 divided by 16 is? Very good. Y squared over 9 minus x squared over 144 equals 1. And from here, it's very clear that A on the y-axis is 3 and B on the x-axis is 12. With this information, I can go and identify. So on the x-axis, 3 and 3. It's very clear that this is which one? Is it 2 or is it 4? It's 2 because it's the vertices are at 3 and negative 3. So it is Roman number 2. Good, perfect. Anything else? Anything else? Other questions? Other questions? Okay, so let's start chapter 12 then. And we're looking at 2 sections. If you find something else, I can stop and go back to it. So if you have anything else. Okay. Yes, yes, go ahead, please. Yes. Yes, that's fine.
11.1, 47.
Okay, let's look at 47 and 11.1. 47. So in 47, find the equation of the parabola whose graph is shown. So we are told that the parabola passes through 0, 0, and it passes through 4, negative 2, and the parabola is of this type. A parabola of this type, is it a function or not? It's not a function. So it should look like this. Y squared equals 4px. So this is the equation that I am thinking of. Is that clear? Okay. So I already know a point. Actually, I know 2 points, but the origin will not help me. Because when this is 0, and I haven't found anything. So this point cannot give any information. Because when x is 0, y is 0, and I get 0 equals 0. So I didn't discover anything. But this point tells us what? That when... Right. So negative 2 squared equals 4p multiplied by 4. Is this okay so far? Okay. So then 4 equals 16p. I will simplify by 4. So then I get p equals 1/4. So then this, it's way too far, but what will this line be? X equals negative 1/4. Awesome. Determining p is sufficient to determine the parabola. All I have to do is just plug it back in. So it appears that the equation is y squared equals 4 times 1/4, which is 1, and x. Very good. Any questions? Any questions on 47? Now, if I were to ask you, what is the axis of symmetry of this parabola? Please give me the axis of symmetry of this parabola. Awesome. Y equals Correct.
Sorry.
Y equals 0 is indeed the axis of symmetry of this parabola. It's the line this time, because the parabola looks like this, it's the horizontal line passing through the vertex. For a parabola like this, opening upwards or downwards, it's the axis of symmetry is the vertical line going through the vertex. But if it's this, it's the horizontal line going through the vertex. Good. Anything else? Are we okay? Okay. Are we meeting tomorrow here from 4:30? I'm asking for a review.
Yeah, for review.
Because I'd like to review tomorrow, and I would like to review on Wednesday. And then we decide when we would like to take the test. Would you like to take the test in the testing center?
Test as in the final? Or?
No, the final is next week, next Monday. And we start here at 5 and you have till 9 to the final. But I would like to review for this test, just go through the ellipse and hyperbola, and although we had this now, but maybe we want to review chapter 12 tomorrow. Now my calculus class will be here and they will have questions too. So I will make sure that I go from one class to the other, right in here, and do one problem from each.
Okay, I'll be here tomorrow if you're having class. So
Yes. Now if you want to come earlier than 4:30, I'll be here for you.
you said this chapter test is just going to be in the testing center, or?
Unless we decide to take it tomorrow, or we decide to take it on Wednesday. I wouldn't like to use tomorrow and Wednesday, either or, I should say, for test. I would like to review. But also you can say, for the final exam, we can review on Saturday. If you show up to review on Saturday for the final, then we can have this test on Wednesday and review tomorrow. But at the end of the day today, before you leave, you have to let me know what you would like to do. So just think about it, okay? Okay. Good. Other questions from conic sections? Christy, do you have anything else?
No.
Shane? Andrew? Parker? Okay, good. So let's start chapter 12 then. Okay. In chapter 12, we will look at sequences. That's the first. Well, only two sections, 12.1 and 12.3. That's it. So that's, yes, that's what we have here. 12.1 and 12.3. These are the last two sections. Okay? Okay, in 12.1, we will talk about sequences. We will talk about the summation notation. And we will also mention infinite series. In 12.1, we will talk about geometric sequences. Okay, so 12.3 and infinite series. Geometric sequences. Okay, so let's start with the definition of a sequence. What is a sequence? Here's a sequence. I'm going to copy an example from your book. We are on page, at the end of 12.1, and that is on page 792. 792. I don't see a starting point that I was looking for, so I'm going to make one up. So a list of numbers of this kind, let's say 1, 2, 3, 4, 5. The general term or generic term is a sequence. I just made one up. The first term of the sequence is 1. The second term of the sequence is 2. The third is 3. And notice exactly 3 dots. Not more, not less. And this is the general term. General term of the sequence. Now, in general, a sequence is denoted in the following way. A1, comma, A2, comma, A3, comma, dot, 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 AN, dot, dot, dot. Where, again, AN is a general term. Now, this was just an example of a sequence. So find the first 4 terms and the 100th term of the sequence. So we are looking at page 792, and let's say we start with problem 4. We have the generic term or general term is given to us as 2n plus 3. Now, we have to understand or remember, if you want, that n, unless otherwise stated, starts with 1, 2, 3, and so on and so forth. So we're asked to find the first 4 terms and the 100th term of the sequence. So notice that for the first term of the sequence, n is how much?
1.
For the second term of the sequence, n is 2. For the third, and for the nth term is n. So here I'm asked to find the first 4 terms and also the 100th term. So how do I address this?
So we just plug in 1, 2, 3,
That's
4,
it.
100.
Exactly. So the first term will be 2 times 1 plus 3, which is 5. The second term will be 2 times 2 plus 3, which is 7. The third term will be 3 times 2 is 6, plus 3 is 9. Can anyone already give us the 4th term?
Oh. 11.
Good. And the 5th term? Okay, very good. And now we want the 100th term. Let's look at the graphing calculator for a second. I have not tried this with the software. I'm hoping that it works. So go to the mode, and please change from function all the way to sequence. All the way to sequence. And get out of there with second and quit. And let's go to y equals. If you notice and you look carefully, you'll see the whole thing is totally different now. The whole viewing window now is different. Agreed? Okay, so now I would like to, so the minimum value for n is 1 unless I need to change it. There are certain sequences that start with n equals 5. But if I'm not specified, then the minimum value for n is 1. Okay, so now I will have to plug in 2 times n. The variable is still in the same spot where you have x, t, theta, and so on and so forth. And we have plus 3. Say it again.
Is there a special n? Oh,
It's the x. It's the same sequence.
That's all right.
Okay, that's okay. And now you can get out of there with second and quit. And I want to evaluate this general term for different values of x. So here's u. Do you see u under the comma? But actually it goes with 7. Sorry. So second and 7, it calls the sequence that we put in the general term, and in parentheses we want to evaluate it for 1. I'm going to recall, and this time evaluate it for 2. And let's say I got the picture. Now I want to recall it, and I want to evaluate it for 100. And close the parenthesis. Any questions? This is how I evaluate the sequence. I have the general term. I put it in as if I would put in a function the same way. And I just evaluate it for the values that I'm asked to evaluate. Any questions on this?
Why is it U? Is it yes?
Because we plugged it in U. If you go back to y equals,
Okay.
that was the U. So it's no longer called Y. It should have been called AN or something else, but for some reason the calculator has U. Is that okay?
Yeah.
I'm sorry?
What do you like?
In Y equals. So we put it in, that's our U of N, and this is your U,
Right here.
right, in blue. So you have to activate it with the blue,
See. Gotcha.
and now you plug in whatever you need.
Awesome.
Okay, so this is the mechanism, this is how you check. You don't have to do this by hand, you don't have to multiply and add, you can plug it in and find the values. Okay, is this clear? Do we need another example of how to determine terms, given the general term? Are we okay with this? Okay, so look at problems 3 to 12 and say, yes, I need to see another, or we move on.
The ones that exponent, does that change?
Which one do you want to work on?
9.
Okay, we want to work on 9. Let's work on 9. Very good. So we have an equals 1 plus -1 to the nth power. The same question, the first 4 terms and the 100. So let's go back. Oh, I'm already there. Okay, so in y equals, clear what you have, and let's put in, it's 1 plus, in parentheses, -1. Everything is the same, like you would plug in a function. Okay, so I swallow the 1. I don't know why. Oh, it already took me somewhere else for some reason. Okay, plus, in parentheses, -1 to the power of n. So this is the general term of the sequence. Any questions? Now, let's see if it works with the table. It should also work with the table. Yeah, here it is. Okay, but make sure that you have second and table set, because I forget always. It goes back to default. So second and table, you can just plug it in. So I have to plug in 1, 2, 3, 4, and 100. Exactly as a function. Like I would perform the same operations with a function. So in this case, A1 equals 0, A2 equals 2, A3 equals 0, A4 equals 2, A100 equals 2. Clear enough? Yes? Okay, perfect.
What about,
Yes?
11, just instant?
Number 11,
Yeah, I'm not gonna like,
same thing.
this is, alright.
N raised to power n.
Okay. So this is gonna be like 1 to the first and 2 to the
Exactly,
third.
to the first and 100 to the 100.
Okay.
Exactly. Very good. Is that okay? Okay. Now, sequences can be given to us in this way, where we have the first few terms. They can be given to us given the generic term or the general term, or they can be given by a recursive formula. Sequences given by a recursive formula. Okay, let's see what that means. Okay, problems 13 through 18. Let's suppose we start with 17 and then I'll let you choose another. So we are given the generic or general term in the form of a sum of other terms. Okay, so we have A1 equals 1 and A2 equals 2. So let's see what we are asked to do here. Find the first 5 terms of the given recursively defined sequence. Okay, this is the first term. This is the second term. That part was easy. So I need to determine A3, and I need to determine A4, and I need to determine A5. So when n is 3, this is a
3 minus 1.
2 plus a 1. But 2 plus 1 is 3, so this is 3. When n is 4, how much is this? A3 plus A2. Not 2, but A2, correct? Okay, very good. So then I have the sum of the previous two terms. 2 plus 3 is 5. Okay, A5. When n is 5, then this is a 4 plus A3. We know it. It's A2 plus A1, A3 plus A2, A4 plus A3. Okay, A4 plus A3 is 8. Any questions? Let's see how we plug this in the graphing calculator. So let's go to y equals. Clear. Now, I am not sure how to plug in a1 equals 1 and a2 equals 2. But here's how we plug in the formula. un is u second and 7 in parentheses n minus 1, close the parenthesis. Can anyone tell us how to continue? Plus
U.
exactly the same function u of a different argument, which is indeed n minus 2. Close the parenthesis. So now let's go to second and table and see what happens. Ah, it gives me an invalid error because I have to go back. There is no way I can put, I don't think there is any way I can put in A1 and A2 because they are given already to us, but I have to start with n at which value? I cannot start at 1. I have A1 and A2. Look at what we wrote.
Oh, A3.
Exactly. I have to start with minimum of 3 because I can plug in. I can plug in a negative number, right? 1 minus 1 would be 0, and 1 minus 2 would be a negative number. All these sequences start with n from 1 or above 1. So let's see what happens now. Because it doesn't recognize or something, I don't know how to, in this calculator, how to plug in. Okay, let me see if, I don't want to spend too much time on this. We understand what's happening, so n minimum, u of n minimum is 3, let's see. Okay, so let's see what happens now. No. Because we had this condition of A1 and A2, I wanted to try and see if it works. So you know how to put in the recursive formula, but we are having difficulties with these two because it doesn't give me the right answer. I will still think about it, how to, if there is a way, I doubt, but it could be. If there is a way of putting this sequence in the way it is given like this. So I had to start with 3, but it does not recognize the first two terms in the graphing calculator. There is no need to put this in the graphing calculator, but I just wanted to see if there is a way. Okay, any questions? Any questions here? Okay. Find the nth term of a sequence whose first several terms are. I'm looking at problems 25 through 32. Let's say we start with 26. So we're given the sequence now. Remember, we have 3 ways. I either have a list of numbers, either have the general term, or I have what? What is the third option? The recursive formula. Okay. In this case, I'm given the numbers, the terms of the sequence, to be exact. Negative 1/3, 1 over 9, negative 1 over 27, 1 over 81, dot, dot, dot. And we're asked to find the general term. in such a way that A1 will be this, A2 will be this, A3 will be this, and A4 will be this. Where is the easiest part? Where will I start? So this is A1, this is A2, this is A3, and this is A4. So it will be the starting point. Say it again. No. So I want to determine a formula that has n in it in such a way that when I have n equals 1 and I plug in n equals 1, I get this term.
So A1. Sorry, A1.
No.
Variables 1.
So I will get something here that has n in it, has n in it, some sort of expression. Like, for example, this one. This is an expression in which if I plug in 1, I get this. If I plug in 2, I get this. And these are the terms of the sequence. Now, I'm going backwards. I am given the terms of the sequence, and I'm asked to find that general term in which if I make n equals 1, I get negative 1/3 in here. If I make here n equals 2, I get 1/9. If I make n equals 3, I get negative 1/27. If in here I make n equals 4, I get 1/81.
So, negative 1/3 is the n.
So let's try. Let's try. Negative 1/3, and you want everything in parentheses to the nth power. Okay. So when n is 1, do I get that? When n is 2, do I get that? When n is 3, do I get that? When n is 4, do I get that? Perfect. So we really like to write it like this, separate. Negative 1 to the nth power over 3 to the nth power. But everything you said is perfect.
We can take either or.
We prefer this, but this is perfect as well. Does it make sense? Is this the general term of the sequence? Yes. Perfect. Okay, let's look at one more. Let's say 28, in which we have 5, negative 25, 125, negative 625, dot, dot, dot. Same question. We're asked to find the general term an of the sequence. Oh, and also I wanted to show you how to graph that, a sequence. With the graphing calculator. I don't want to forget that. So whatever you give me, when you plug in 1, the answer should be 5. When you plug in 2, the answer should be negative 25, and so on and so forth. Let's discuss the terms without the sign. Leave the sign alone for a moment. What will you say?
Up for power.
Right.
5 squared equals 25.
So I will write 5 raised to which power? N, indeed. So forget about the sign for 1 minute, okay? So if n is 1, I get this. If n is 2, I get this. If n is 3, I get this. If n is 4, I get that. Now let's discuss the sign. Remember, the odd number, when n is 1, 3, 5, those are positive. So I cannot have negative 1 to the nth power, because negative 1 to the nth power will give us all the odds negative. But this is reversed. So instead of the power n, I will have n plus 1. So negative 1 raised to n plus 1. Let's try now. When n is 1, that power is 2, and it kills the negative sign. When n is 2, I have power 2 plus 1, which will stay negative. When n is 3, I have n plus 1, which is 4. That will change this into positive. Is that clear? Yes? Okay. That is the general term of this sequence. Okay, let's look at one more. Let's.
What would the answer of that be?
I'm sorry.
What's the answer? -1 to n plus 5?
-1 raised to power n plus 1 multiplied
Oh, it is that.
by 5 raised to power n. Is that okay?
Yeah.
Okay. Okay. Let's talk about partial sums of a sequence. Partial sums of a sequence. So let's write our sequence again. A1, comma, A2, comma, A3, comma, dot, 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 comma, AN, comma, dot, dot, dot. S1 is the first partial sum. And I said not to forget to show you how to graph. We can do it later too, but I like to, what do we have here? Oh, I have to clear that. So give me a previous sequence that we looked at.
5, -1, 5.
So what was 2u? Let's look at another one. Right? Let's just make one up. Let's say n divided by n plus 1. Okay, so there's a sequence n divided by n plus 1. So now I have to adjust the viewing window because n cannot be less than 1. So I'm going to go to, that's okay, x minimum, -1, not more than that. X maximum is fine. Y, they're all terms positive, so between -1 and 4, and here's my graph. So this is the sequence, n over n plus 1. Of course, this is not a function, right? It only gives us dots or the pairs. When n is this, a of n is whatever, a of 1 is, or a of 2, and so on and so forth. You can connect them. They're not a continuous function. Okay, coming back to the sequence, the partial sums. Okay, S1 is the first partial sum, and it equals A1. What do you think about the second partial sum? What do you think? Wild guess. The second,
A2.
A1 plus A2. A1 plus A2. This is the second partial sum. What about S3? Uppercase S3. What do you think? A1 plus A2 plus A3. The sum of the first three terms. What about S4? The sum of, and now I'm going to jump to the nth partial sum. So this is the nth partial sum. What do you think the nth partial sum will represent? And of course I can continue forever, but I'm interested in the nth partial sum. A1 plus A2 plus A3 plus dot dot dot, and here the last term will be AN. Very good. That's the nth partial sum. And now I'll go to, again, page 793. Problems 37 through 40. We'll have applications of this, and you'll see they're quite interesting. Find the first four partial sums and the nth partial sum of the sequence. Ready? So let's look at 38. AN equals 1 over n plus 1 minus 1 over n plus 2. They want the first four partial sums. So they want S1, S2, oops, S3, S4, dot, 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 and they also want Sn. Okay, so how do I find S1? Good. Which is 1 divided by minus. Do not add. Actually, I do have to add the first 4 because I'm asked to add them. Yeah. So the least common denominator is 6. 3 minus 2, 1. Okay, let's find S2. What does S2 equal to? Perfect. A1 plus A2. I already have,
So it would be 1/6 plus 1.
yes, or let's write it as 1/2 minus 1/3 plus 1/3 minus 1/4. And I like that. So 1/2 minus 1/4 is 1/4. Okay. In this case, we also look at the pattern. And we need to look at the pattern because of the Sn. How could I add Sn, right? Just by simply looking at the pattern. Okay, S3. Of course, A1 plus A2 plus A3. Let's look at the pattern. Don't add. So we have 1/2 minus 1/3 plus 1/3 minus 1/4. This is A1 and A2. Can anyone dictate A3? One-fourth minus look what happens. I only have to subtract 1/5 from 1/2. So 5 minus 2 is 3. 3 over 10, I'm sorry. Okay. Any questions? Is this okay? So now S4. A1 plus A2 plus A3 plus A4. I copy everything I have so far. 1/2 minus 1/3 plus 1/3 minus 1/4 plus 1/4 minus 1/5 plus I need A4. Okay, indeed. And minus 1 over? Good. Everything cancels except 1/2 minus 1/6. The least common denominator is 1/6. So I have 3 minus 1, which is 2, which is 1/2. Of course. I don't know. No excuse. No excuse. Okay. So now I would like you to give me Sn minus 1. And then eventually I want you to give me Sn. So Sn minus 1 is A1 plus A2 plus A3 plus A4 plus dot 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 plus it's not raised to. I cannot say A to the n. I can say A n plus first. Right? So when we had 4, we stopped at 4. When I have n minus 1, I have to stop at n minus 1, correct? Okay, like here, and I'm coming back to that. What will you say? A1 plus A2 plus A3 plus A4 plus dot 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 plus an minus 1 plus an indeed. An indeed. Okay, so let's see what we have here. Obviously, no matter what, right, these terms go away. And the last one, right, we saw the pattern. So when we had 1, these two were 1/6. But when we had 2, everything canceled in between. And we had the first one and the last one. Again, when we had 3, everything canceled in between. And we had the first one and the last one. The same with A4, with S4, the first one and the last one. So what will you say this should equal to? 1/2 indeed,
Plus 8.
but it has to be minus, right? Minus. Now in this formula, I replace n by, awesome. N minus 1 plus 2 is 1 over n minus 1 plus 2. N minus 1 plus 2.
It should be just plus 1, right?
Yes,
Yeah.
that's all I want you to say. N plus 1. So this is the one before the nth sum, partial sum, right? But that's not what we want. So we want the next one, the last one. So we have 1/2. All this, everything in between will cancel out, and we will have the last term as when n is n. Exactly. Plus 2, right? Okay, very good. Minus 1 over n plus 2. Yes, I can find the least common denominator. And then n plus 2 minus 2. So it's n over 2 times n plus 2. Very powerful result. We're able to add the first n terms of a sequence.
So that's the end right there?
Yep. Any questions? Okay. If I have, for example, 1 plus 2 plus 3 plus 4 plus ... plus n, we have a very nice and condensed way of writing this. So what is the operation among these terms? Which operation do we have? What do I do with these terms? What is the operation between any of the two terms? Adding or sum, right? Okay. So there is a notation that uses the letter S, but this is not suitable for what we are trying to do. And you'll understand in a minute why. It's not a good enough symbol. Therefore, that was, instead of writing S for standing for sum, because I'm adding these terms, we will be using the Greek letter sum, S. Okay? So here's the Greek letter S, which is the same with our Latin S, right? However, this is the notation that is more suitable for what we are trying to do. So instead of listing all this, I don't want to list this. I want to tell you this. So this is what it's called, the summation notation. Also called the sigma. That's the Greek letter S. Sigma notation. The sigma notation has a lower limit and has an upper limit. Lower limit, in our case, is 1. Can anyone dictate the upper limit? N. Very good. It could be infinity when we get to infinite. Yes, it could. What is this? That is the general term AI, which is I, also denoted by AN, which is N. Same thing. However, this time, I have to use this specific index. Your book uses K, you can use I, you can use J. There are different notations, it's the same thing. So I can have the sum from j equals 1 through n from aj. I can have the sum from k equals 1 through n from ak. It doesn't matter. What will this mean? When k is 1, I have a1. The summation notation tells me to add. When k is 2, I will be adding k2. Again, the summation notation tells me to add. When k is 3, I will add a3 plus dot, dot, dot. What will be the last term? Not to the n, but an. So this is a condensed way of writing something that could go on for a long row. It's just a different way. Of course, once this notation was invented, 3 properties come along with it. Here are the properties. Properties of the sigma notation. 2 of them can be condensed, and I will condense them. The sum from I equals 1 through n from ai plus bi. And we can have subtraction. What do you think this will equal to? This is the same with the sum of ai from I equals 1 through n. And what will you say then? Plus or minus the sum from bi from I equals 1 through n. In other words, it says that if I need to create the sum of 2 generic terms, I can determine the sum of one, I can determine the sum of the other, and then add them up. This is property number 1. You can consider it 2 properties, one for the sum and one for the difference. And the second one is when we have a constant, not depending on I, times ai from I equals 1 through n. What do you think this means? It means c times a1 plus c times a2 plus c times a3 plus c times dot, 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 and plus c times an. What do you think will be the common sense to do here? And there are 2 words, key words, in all algebra, pre-calculus, calculus classes. What are they? And factor. So which one do you think, if I have c times a1 plus c times a2 plus c times a3 plus dot, 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 c times an, what could I do?
Factor.
Yes. So this constant goes in front. Indeed. So now I would like to find a few sums, and with a graphing calculator as well. Okay, find the sum, problems 41 through 48. Let's say one that looks difficult. From I equals 1 through 3, from I times 2 raised to I. Can anyone give us the first few terms? I want to see that we understand and make sure that we understand how this works. And since it's 3, please give me all 3 terms.
So it's 1 times 2 times 1
Plus?
4 squared 16.
So plus, when I is 2,
Yeah, so 2 times 2.
2 times 2 squared. I need to show to everyone what it is, and then we can add them. And then plus?
3 times 2. 2.
Indeed. Do we all agree with this? When I is 1, I get a term, plus when I is 2, I get a different term, plus when I is 3, I get a different term. Would you agree? Is this okay? Yes? So indeed, this is 2 plus 4 times 2 is 8, and this is 8 times 3, 24. So what do I get? 34. Correct? Okay, so let's put this in the graphing calculator and determine the sum of a sequence. So let's go to second and catalog. It's 0. Second and catalog, which is 0. And press on S, because I want to jump there. Now let me see why I can't see S here.
It's the LL. To the
do-
left.
okay, right, okay, thank you. So press on S. I'm looking for the sum, SUM, with parenthesis, SUM. Maybe I should go to T and then go back up.
It's under math. I found under math.
You found out the math?
Yeah.
Okay, very good.
You clicked a lot.
Okay, here it is. I just found it. Okay,
I just clicked under just under math. So just like summation.
I don't know if I can put a sequence in it. I have to have some of the sequence, so I'm not sure. It could possibly work. You can give it a try. Okay, for now I go to second catalog and I'm going to choose T this time and go back up. Okay, it's also there too. Okay, I need this, SUM. And then I go back to second and T. No, that's not what I meant. I need to go to catalog first. Second and catalog and then T. And go back up to the sequence. That's, I think, it's one way. Okay, I need this one with parentheses. So I have the sum of a sequence. And now the sequence is n times 2 raised to power n, comma, the variable is n, comma, it starts at 1, the lower limit is 1, comma, the upper limit is 3, comma, and we go by unit of 1. Close the parenthesis for the sequence, close the parenthesis for the sum. Are we okay?
I do the comma.
The comma is right there but with parentheses. There is a comma where the parentheses are in the middle. It's right here. Here is next to the left parenthesis.
Oh,
And then you press enter. So again, this is one way. So when we just determine 34, and that's how we got it. You did the same thing?
Well, I used.
You use the summation?
Yeah,
Okay,
and-
so that works.
Yeah.
Awesome.
It gives you like the little symbol and everything, so you just plug in where it's like.
Okay, that's perfect.
Like
I never used that one, but let's do it. So I should have gone back up. I think it's easier. Okay, good. So that's the sum. Awesome. So did you put n?
yeah.
N equals 1 and to 3. That's awesome. So it's n and a 2 power n and just press enter. Awesome. Perfect. So you have both ways. Good. I just want one example here, and we can move on to the last section with a word problem, and we can move on. So let's look at 64. Yes. Okay, so let's look at 64. We are only asked to come up with a yes, write the sum using the sigma notation or the summation notation. Okay, so I just want you to give me the summation notation. What is it? Okay, what is it? I cannot use n. N is the last thing.
Oh, so 1 over
I, natural log I. Awesome.
and then looks like it's I equals 4. Oh wait, I equals 2.
Exactly. And now we have to replace the N because we are given a particular number.
Oh, 100.
100 indeed. Now you understand I cannot use N, right, in the generic term because N is the last term, right? And I goes from 2 to 100. Awesome. Very good. So let's look at a word problem. 72. Compound interest. Helen deposits $100 at the end of each month into an account that pays 6% interest per year, compounded monthly. The amount of interest she has accumulated after n months is given by the sequence. Look at that. Just a very interesting application. 1.005 to the n minus 1 over 0.005 minus n. Let's put it in the graphing calculator because we are asked to find the first 6 terms of the sequence. So what are you going to determine? I. Good. So we're not going to do this by hand. So let's go to y equals. It starts at 1, so clear what you have. So I'm going to plug in 100. And in parentheses, and parentheses again for the numerator, 1.005 caret power n, and then minus 1, close this parenthesis, and divide by 0.005 and minus n, and close the parenthesis. So now, are we okay? Do we all have this in? Okay, so now second and table, I'm going to plug in 1, 2, 3, 4, 5, right? First, Helen deposits, okay, at each month into an account that pays 6% per year, compounded monthly. The amount of interest she has accumulated after n months, just making sure that we're plugging in n months, correct? Okay, so we want 6 terms. 1, 2, 3, 4, I have them. So this gives of interest, yes. Okay, very good. And then 2, and then 3, and then 4, and then 5. And then we want to determine part B, find the interest she has accumulated after 5 years. What do I plug in? 60 months. Awesome. So let's see the interest that she has accumulated in 5 years. How much? $677, $977. Any questions? Is that clear? Good. So let's look at the last section, which is 12.3. Geometric sequences.
Looks like we're the Fibonacci sequence.
Yes, the Fibonacci sequence, it was a mathematician who came up with it. And it has a very interesting application. It's really used in the stock market.
Oh, really?
Yes, to predict.
In the stock market.
Mm-hmm.
The giant
Yes.
circles.
Yes, yes.
Predict
The outcome of particular, yes.
Is it pretty accurate?
I'm not sure, I have never used it.
Oh, okay.
I have never used it. I wish I could give you more information about that.
You should see the stocks then.
I should.
Since you're math,
I should. I'd rather torture you here. I'm just kidding, I'm kidding, I'm kidding.
Yeah.
Yes. Thank you for the advice. Okay, let's finish this up.